Welcome to Splunk and the Weather, as powered by the DarkSky API. My name is Somen Day, and I am a senior consultant at Function One. So we have to show the forward-looking statements. So before we get started, just a little bit about Function One. So we were founded in 2007 with offices in DC, New York City, Toronto, and Chicago. And we've been one of Splunk's premier professional services partners for years now. We've had more than 1,000 successful Splunk engagements spanning across all industry verticals. And some of the services that we provide include installation and upgrades, data onboarding, training, dashboard and app development, products, health checks, and consulting. And our team of Splunk experts is credited with designing the base architecture for some of the largest Splunk deployments to date, and we have aided in developing the standard for enterprise-class governance and data onboarding. So thanks for listening about that. So the famous author and great American Mark Twain once said that climate is what we expect, but weather is what we get. And boy, is that true. As you guys know, we can never fully be dependent on the weather forecast or fully trust the weather forecast. It can never be 100% accurate. And yet, we are indeed dependent on the weather forecasts because we have to plan our lives accordingly. Whether it be something as important as planning a trip or something as mundane as planning your daily commute. We are, in essence, dependent on the weather forecasts. Now, the professionals, the meteorologists and the climatologists, they use a lot of data analysis and high tech stuff to predict the weather and provide us the forecasts. And you'll see that we can use the same type of methodologies ourselves to become our own meteorologists by using Splunk. So I hope to demonstrate that to you guys with this presentation. So at Function One, we blog quarterly, and we're encouraged to find new and exciting ways to use Splunk. So I was able to integrate the data from the DarkSky API, which is a weather-related engine, with Splunk, and we were able to also utilize the machine learning toolkit, which I'll get into later. So first, a little quick overview of the DarkSky API. It allows you to look up the weather anywhere on the globe, returning the current weather conditions, minute-by-minute forecasts, and also hour-by-hour and day-by-day forecasts out to 7 days, and observations going back decades. So we're talking a lot of historical data that we can ingest into Splunk. And so there's two types of API requests. The first one being a forecast request, which returns the current weather forecast for the next week in JSON. And then there's also a time machine request that returns the observed or forecast weather conditions for a date in the past or the future, and in the same JSON format. So that's pretty cool. So, DarkSky API. Why is it perfect for Splunk? Well, data can be historical or from the future, and all we need to do is pass in an epoch time variable, and we are all well aware that Splunk can easily implement the epoch timestamping. Also, data can be searched and charted in intervals, currently, daily, hourly, and minutely. And this takes advantage of Splunk's time charting capabilities as well. And last but not least, data is returned in neat and clean JSON, which we all know that Splunk can ingest JSON data fairly efficiently with just a few rules in props.conf. So for all those reasons, it's a match made in heaven. So the first thing we were able to do is is ingest a lot of historical data and plot out some dashboards and visualizations. So for instance, here we're visualizing the max versus min temperature every day over the course of a year. And the geographic location that we pinpointed was Lower Manhattan, the actual office, the actual Function One office in New York City. And as you can see, we're using the time chart capability of Splunk, and we're also utilizing some of the DarkSky API data points, such as the daily data, apparent temperature, and min and max. Similarly, another visualization here is the precipitation intensity. Now we're just shrinking the time span to the summer of 2016. We're using a different type of time chart here. Same geographic location. As you can see, this looks pretty cool too. And then finally, one last visualization, the average wind speed per day. Now we're shrinking the time span even more to just 1 month in 2016. And you can see, October was a pretty windy month that year. So that was just like one possible thing that we were able to do, right? We were able to ingest a lot of historical data and plot out visualizations. But that's not all we wanted to do. We also wanted to predict the weather. So how can we predict if it will rain or not? Well, the DarkSky API offers fields that Splunk can utilize to forecast rain. For example, the dew point, the humidity, the pressure, and the cloud cover. Now you might ask yourself, well, yeah, I've heard of these terms before, from my local meteorologist, and it's true. Exactly the same way that they use these data points to give us our weather forecast, we're utilizing those same data points, but we're doing it ourselves through Splunk. Now, we also needed to set up a simple eval to create a field that we run the prediction on. So it's pretty simple, as you can see. It's called rain equals, and if the summary field from DarkSky API has the word rain in it, then it's gonna be rain, else no rain. And so here's where it gets cool. We were able to leverage we were able to utilize the machine learning toolkit. And the machine learning toolkit's been mentioned and highlighted a bunch of times so far at Conf, and we didn't know that was going to happen, but we were able to utilize it for this presentation. And as you can see there in the search, we're using the same eval that we mentioned before. We're using the Gaussian algorithm. Obviously we can pick any algorithm we want that might be better suited to this, but I'm not a data scientist, so we didn't really know which particular algorithm to use. But we used this one, and the field to predict was the rain field that we talked about earlier. And the fields we use for predicting are the 4 fields that I mentioned as well: dew point, humidity, pressure, and cloud cover. And then we hit the fit model button. And as you can see, with a fairly high degree of precision and accuracy, we're able to tell whether or not it's going to rain. Now, this is, of course, a pretty simplistic example of how you can use the API and Splunk to become your own meteorologist in a way. However, the same principles that the professionals use, we're using the same type of principles. We're using the same type of methodology, and it's cool to become your own meteorologist this way. So hope you guys enjoyed the presentation. Are there any questions? Yep. Sorry? Oh, go ahead. Yep. Oh, sorry. Yeah, go ahead. Oh, so it was about a 2-year span of historical data, and it wasn't that much. It was about just a few gigs. Yeah. Oh, to be honest, we didn't try to look at too much future data. We didn't leverage that capability yet. Yep.
Cost
Yes.
to the API?
Yes, there is, but it's negligible. I believe the first 1,000 API calls are for free, and then it's like 1 cent per the next hundreds or thousands or something like that. It's negligible.
So apologies if this was already answered, but so we see the results of the prediction formula that was used, but did it rain or did it not rain? What was the actual prediction, and was it correct?
I
Not to
what?
put you on the spot, but
Yeah. Well, I think it did. Yeah, I think it did rain. That particular for what we were trying to plot out. Yep.
Does this integrate well with chloropreth maps?
Yeah, it does because you're providing it's essentially the DarkSky API. One of the two inputs for it is a latitude and longitude. So in that regard, it's gonna integrate perfectly seamlessly with that. Yeah.
More question?
Any more? Great. Thanks, everybody.